Okay guys, we're going to work another practice problem. It is number 19 from page 87. It's an average atomic mass problem. And the problem reads that there are three isotopes of argon occurring in nature. We have argon-36, argon-38, and argon-40. And it says calculate the average atomic mass of argon to two decimal places given the following relative atomic masses and abundance of each of the isotopes. It says that argon-36 occurs 0.337% of the time, which we know that in a decimal it occurs 0.00337. And we're going to multiply that by its atomic mass, its AMU, of 35.97. Okay? And what we're going to do is it tells us that we have argon-38. It gives us its atomic mass unit, its abundance, and then argon-40. And what we're going to do is set them all up like this and add them all together, and that will give us our average atomic mass. So argon-38 is we have an abundance of 0.063. So as a decimal, it's 0.00063. And we're multiplying that by its atomic mass unit of 37.96 and adding that to our last isotope, which is argon-40. It's 39.96. Did that a little different right there. Just put the atomic mass unit first. And multiplying that by its abundance of 0.996, and remember that's 99.6% written as a percentage. So we multiply everything in the parentheses first, add them all together, and we should get an answer of right around 39.95, and that is the average atomic mass. Alright guys, we're going to work 2 gram formula mass problems here. We're going to have water and magnesium nitrate. I just picked these two out. They're not really from anything, but we're going to do the gram formula mass form. Now, on the first step on gram formula mass is first just writing down everything that we have. We know that in water we have hydrogen and we have oxygen. Okay, the next step is we write down how many of each element we have. So we look at the subscripts for that. We see that we have 2 hydrogens, and since there's not a subscript by oxygen, it's an understood 1. And then all we have to do is multiply it by their atomic masses on the periodic table, which we know for hydrogen is 1.00, and for oxygen it is 16.00. Okay, now all we have to do is just work these out. Multiply 2 times 1, which gives us 2, and 1 times 16, which gives us 16. Add those two together and we get the mass of water, which is 18.00 grams per mole. Remember that 1 mole of water is 18 grams. Alright guys, so now we're going to look at the magnesium nitrate. And here we have magnesium, we have nitrogen, and we have oxygen. Now we need to write down how many of each we have. We have 1 magnesium. Since this 2 is on the outside of the parentheses, that means we factor it to both of them. So nitrogen didn't have a subscript, so 1 times 2 would give us 2. Oxygen has a subscript of 3, so 3 times 2 is 6. And we just multiply that by their atomic masses. The periodic table, magnesium has an atomic mass of 24.31. 4, and nitrogen has an atomic mass of 14.00, and oxygen has an atomic mass of 16. We multiply those out and we get 24.31, 28.00, and 96.00. Add those up and the answer that we get is 148.31 grams, and that is grams per mole of magnesium nitrate. gram formula mass problem, And we're going to work the gram formula mass of magnesium phosphate. Now the equation for that is Mg3PO4 2. Okay, just work it the same as we always do in gram formula mass. We have magnesium as one of our elements, phosphorus as one, and oxygen as one. So then all we do is we count the number of atoms in each, and we see we have 3 magnesiums. We have, remember that 2 distributes out, so we have 2 phosphorus, and we have 8 oxygens. Look on the periodic table, get the atomic mass for each. We know that magnesium is 24.31. Phosphorus is 30.97. And oxygen is 16.00. Multiply those out, and we should get 72.93. 61.94 and 128.00. Add those guys up and we should get a gram formula mass of 262.87, and that's grams per mole of magnesium phosphate.